Okay, in this video, I will show you what do we do if we have irreducible quadratic factors. So, for example, our qx is x cubed plus 4x, and when you factor this polynomial, it can be factored into x times x squared plus 4. Now, this factor x squared plus 4 is a quadratic factor. And you see, we cannot continue to factor this quadratic factor, right? Because we only discuss the real number. So there's no way we can we cannot factor a binomial like this. If this is x squared minus 4, then we will be able to continue to factor. So in this problem, we have two different type of factors. One is a linear factor. A second one is a irreducible quadratic factor. Now, for this linear factor, the pattern we are using is a over x. Now, for this quadratic factor, the pattern we are using is bx plus c over x squared plus 4. So the difference is, if it's a linear factor, the numerator is always a number. But when it is a quadratic factor, the numerator is some number times x plus another number. And then next, we need to determine a, b, and c. So we combine these two terms. So we multiply the first fraction by ax squared plus 4. And we multiply the second fraction by x. Now, by comparing these two numerators, we can find a, b, and c. So a squared, a times x squared plus 4a plus bx times x. So it is bx squared, and c times x. Now, since 4a must be equal to 4 because they are the only each of them is the only constant on each side. So a must be equal to 1. And the next, since cx must be equal to 4x, so c equals 4. And bx squared plus ax squared must be equal to 3x squared. Since we figure out a is 1, therefore b is 2. Now, after we determine the values of a, b, and c, we can rewrite this rational expression into. Now remember, this is the pattern we are using, right? So a is 1, so the first fraction is 1 over x, and the second fraction is bx plus 4, which is 2x plus 4 over x squared plus 4. Okay, now let's look at after we use partial fraction to rewrite this rational expression, then how to find the integral. So now this integral is equivalent to the integral of 1 over x dx plus the integral of 2x plus 4 over x squared plus 4 dx. So I continue to split the second integral into sum of 2x over x squared plus 4 dx plus 4 over x squared plus 4 dx. Okay. Now the first integral, we can use the logarithmic function. So this is the natural log of the absolute value of x. For the second integral, we can solve it using u substitution. And also you can use trigonometric substitution. I mean, either way is fine. If I use u substitution, I can net u be x squared plus 4. Then du over dx gonna be 2x. So dx gonna be du over 2x. So we can rewrite the second integral into so 2x over u times du over 2x into the integral of 1 over u, and this is equal to the natural log of the absolute value of u, and because u is x squared plus 4, so this is the natural log of x squared plus 4. Now here we can drop the absolute value sign because x squared plus 4 is always positive. So the second integral is natural log of x squared plus 4. Now for the last one, we can use the the trigonometric substitution we started today. Because x squared plus 4, this has the pattern of u squared plus a squared, and we said if we have this pattern, we should let u be a times tangent theta. So here, since a squared equals 4, so a is 2. So we let a be 2 times tangent theta. If x is 2 times tangent theta, then dx gonna be 2 times secant square theta d theta. And x squared plus 4, this will be the square of 2 times tangent theta plus 4. And this is equal to 4 times tangent square theta plus 4. So this is 4 times secant square theta. So we can rewrite this integral into 4 over so x squared plus 4. I can rewrite as 4 secant square theta. And dx we can rewrite as 2 secant square theta d theta. So secant square theta is cancelled out. And 4 is cancelled out, so we are left the integral of 2d theta, which is 2 theta. And now what is theta? Because since x equals 2 times tangent theta, therefore tangent theta gonna be x over 2. And if tangent theta equals x over 2, according to the definition of the inverse function, theta is inverse tangent of x over 2. So the last integral is equal to inverse tangent of x over 2. Right? So after we use a partial fraction, we split this integral into 3 integrals. And for each integral, we have an appropriate way to use to find the answer.